educators, and welcome to today's Grade 11 Math Show, proudly brought to you by Macmillan. Today we have a special revision lesson on functions. We have selected highlights from lessons shown early in the term to help you revise and prepare for your June exams. You can download the notes for today's show from learnextra.co.za/live. Now it's time to get on with today's lesson. Please post your comments and questions on our Facebook page on facebook.com/learnextra or on Twitter @learnextra so we can help you with your revision.
Okay guys, so I'm going to try and just rush through this really quickly, but hopefully in depth, and hopefully you guys really understand what I'm doing. This is an exam type question and it comes straight from your Macmillan textbook, and we're going to look at answering a typical exam question all about parabolas and straight lines. Okay, so this is from the Keeping Maths Simple grade 11 learners book, page 175, and this is exercise 5.21 number 3. Okay, so that's where this comes from if you would like to go over this yourself. Okay, so it says the equations of the graphs shown in the sketch are, and it gives you your parabola, and then it gives you the equation f of your straight line. Okay, hopefully you guys can see this diagram nice and clearly on your side. Okay, so we've got G is your parabola, and then we've got f as your straight line. First question says, give the coordinates of D, the y-intercept of both graphs. Now guys, some of you who are quite good at maths and you find all of this stuff really easy, you can see straight away that your y-intercept of your parabola is -24, and the and the y-intercept of the straight line is also -24. Okay, but we're going to go through it just in case there's someone at home who doesn't understand how do we get there. Okay, you can see that at the point D, they both have the same y-intercept. How do we find a y-intercept? To find the y-intercept, we say let x equal to 0. So I'm going to take the simpler one. All right, we've got f of x is equal to 3x minus 24. I'm going to use that one. You can see that they both have the same y-intercept, so we could use either one. So if I say let x equal to 0, basically what it means is wherever there's an x, I substitute a 0. So I'm going to get 3 times 0 minus 24. So therefore we get 0 minus 24 is -24. So my y-intercept is -24. Remember, we want this as a coordinate. So therefore D will be the point. X is 0. Y is -24. Okay, so that's the first part. Nice and easy. Next part. We are then asked to calculate the coordinates of A and B, the x-intercepts of G. So if we go back up here, there we go, A, there's B, the x-intercepts of the parabola. Okay, so let's see if I can remember that equation in my head. We've got g of x is equal to, I think it was -x squared plus 10x minus 24. But let's just go back and double check. So it's -x squared plus 10x -24. Fantastic. All right, how do we find x-intercepts? We say let y equal to 0. Now remember your function value g of x, that represents your y values. So therefore if I say let y equal to 0, I'm going to get -x squared plus 10x minus 24 is equal to 0. And then to make things simpler, I'll divide through by the negative. So I get x squared minus 10x plus 24 is equal to 0. We now have a quadratic equation which we can factorize into 2 brackets. So we get x minus 6 times x minus 4 is equal to 0. So therefore, straight from there, we let each bracket equal to 0, and I get x is equal to 6, or x is equal to 4. Guys, they wanted you to find the coordinates of A and B. So a lot of times people leave it at that point, which technically, I mean, the answer is right, but you haven't completely answered the question. A is the point. Okay, if you go back up to your graph. Okay, have a look. A is the first x value, B is the second x value of your x-intercept, so therefore obviously A is smaller than B. So therefore A is going to be the point 4, 0, and B is going to be the point 6, 0. Okay, all right, the next part. So far, easy stuff, finding x-intercepts and y-intercepts. The next one says, determine the coordinates of C, the turning point of G. So if you look at your graph, there we go, there's C sitting there. We want to know what is the coordinates of the turning point. Now, if you notice, your equation is given in the form ax squared plus bx plus c. In other words, it's not written in the form where the square has been completed. Because if the square is completed and you've got a parabola in that form, it's easy to just read off your coordinates of your turning points as minus p and q. But we don't have that. We are given the equation in standard form. We need to find the turning point. How do we do that? Okay, you'll remember early on in the lesson I told you to find your axis of symmetry. We say x is equal to negative b over 2a. Okay, then if I want to find, so this is the x value of your turning point. If I want to find the y value, I substitute that x value, whatever the x value is, into the equation. Okay, and that will be the y coordinate of your turning point. All right, so how do we do it? We go to our equation. We've got and remember, please, 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 always take it from the original. Don't take it from the one that you've changed in your sum when you were trying to find x-intercepts. You need to deal with the original equation. Y is equal to negative x squared plus 10x minus 24. Okay, if you start changing the signs in that, you're going to get the sign of your axis of symmetry incorrect. Okay, so b, remember, is the constant in front of the x term. So b is going to be 10, and then a is going to be the number in front of your x squared term. So a is negative 1. Okay, so my axis of symmetry is x is equal to negative b, which is 10, all over 2 times a, which is negative 1. Okay, simplifying that, I've got minus 10 over minus 2, which is 5. Okay, we need to find the y value that corresponds to that axis of symmetry. So we need to find the y value of the turning point. So I substitute 5 into my equation. Sorry, that should have been a g. Okay, so I substitute that into my equation. So I go g of 5, and wherever there was an x in the original function that was given to me, I substitute 5. So I've got minus 5 squared, all right, and then it's going to be plus 10 times 5, and then minus 24. Okay, all of this you can put straight into your calculator. So we've got minus 25 plus 50 minus 24. Okay, so we should get an answer of 1. 50 minus 25 is 25. 25 minus 24 is 1. So therefore, my turning point, which was C, is going to have the coordinate x is 5 and y is 1. Okay, guys, so if I go to the graph and show you where we're at, okay, that point C, there we go, that point there is x is equal to 5 and y is equal to 1. Okay, so hopefully you're all with me up until this point. We've only got 2 parts of the question, 3 parts, so I can't count. We've got 3 parts left to do, so let's get into it. Okay, So we found the coordinates of the turning point. Next, we need to calculate the coordinates of E, which is one of the points of intersection of F and G. Intersection, remember that means where the two graphs meet, okay? So if we look at E, this is the point where the two graphs intersect. Another point of intersection would be D. Okay, they also intersect at the y-intercept. So how do we find E? Simple. If you're looking for points of intersection, you need to solve these two equations simultaneously. All right? So we're going to use simultaneous equations to find the point of intersection. And this is D. We had f of x is equal to 3x minus 24. And then we had g of x is equal to negative x squared plus 10x minus 24. All right, let's just double check our equations. 3x minus 24, and we were dealing with negative x squared plus 10x minus 24. So here I've got, remember, f of x and g of x really represents y values. So it's like saying y is equal to 3x minus 24 and y is equal to, we want to see where these two values correspond. Okay, so I can call the straight line, let's call that equation 1. And then we can call the parabola, the defining equation, equation 2. Remember, with simultaneous equations where we're using the method of substitution, I'm going to substitute equation 1 into equation 2 and solve simultaneously. So wherever there is a y, I'm going to put in 3x minus 24. So that means I'm going to get 3x minus 24 in place of this y is equal to negative x squared plus 10x minus 24. All right? Okay, so we're going to take everything over to the left-hand side. We get x squared plus 10x, we bring it over, plus 10 becomes a negative 10. Negative 10 plus 3 is negative 7x. And then we've got minus 24, taking it over, it becomes positive 24, so they cancel off. All right, so we factorize x into x minus 7 is equal to 0. So therefore, x is equal to 0 or x is equal to 7. The coordinate x is equal to 0 was the point of intersection at D. So x is equal to 7 will be the point E. All right? I've got the x value. I need the y value. So all I do is substitute into either of the equations. I'm going to use the straight line, but really you can use either one. You'll get the same answer. And we get 21 minus 24, which is negative 3. So E is the point, x is 7, and y is negative 3.
Okay guys, I hope you're enjoying this revision session. If you are struggling and need help, remember to post on the page or send an email to helpdesk@learnextra.co.za. Now it's time for a break, so don't go away. We'll be right back. Welcome back guys. I hope you are getting into the idea of revision. Please let us know how you are doing. I'd love to chat to you on the page or on Twitter. Enough of the chat. Let's get back to revision now.
Now when it comes to exponential graphs, they can give you a whole number of different scenarios. So I'm not going to do one set method, but generally, because remember, the defining equation for for an exponential graph is y is equal to a times b. See, there's quite a few unknowns here, hey? Look, q is unknown, p is unknown, b is unknown, and a is unknown. And it is very, very unlikely, in fact, it probably will never happen where you would be given all 4 unknown values to find. Okay, so generally you'd have to find 3 or more of those unknown coefficients in this equation. Okay, so we're going to look at an example where they give you the value of A, and you've got to find the value for B, P, and Q. All right. Guys, if you're following in the textbook, this is coming from Keeping Maths Simple, grade 11 learner's book, page 165, and this is exercise 5.19. We're looking at number 6. Okay, so that's if you've got the book, you can follow along there. All right, we are asked to find the equation of the graph y is equal to b to the power x plus p plus q. Hopefully you can all see that the value of a is 1. Okay, there's just a 1 here in front of the b. There's no other, there's no need to find the value for a because it is given. Okay, so we can forget about the a value. We've already got it. Okay, hopefully you all agree that the next easiest value to fill in is the value of the asymptote, so the value of q. And if you look at the graph, you see that the asymptote is at that point -4. So therefore, the equation of the asymptote is y is equal to -4. Okay, that's your horizontal asymptote at -4. So it's quite easy to see what the value of q is. So our equation now goes like this. Y is equal to b times x, b to the power x plus p minus 4, because we now know what the value of q is, so we can simply fill it in. Okay, so your equation, there's now less unknowns. Now we only need to find the value of p and b. All right, so we know that q is -4. Okay, how do we find the value of p and b? If you look at the graph, you'll see that they've given you 2 coordinates. They've given you the points 2 and 4, and then they've also given you the point -1 and -3. So those are 2 points, let's just call them A and B. They've given you 2 points, A and B, that lie on the exponential graph. So if you've got 2 coordinates, now think about it, you've got 2 coordinates and you've got 2 unknowns. How are you going to solve for the unknowns? Okay, hopefully you all remember your grade 10 work really well, and you would have revised it at the beginning of this year as well. It's called simultaneous equations. Okay, so we've got 2 coordinates, we've got 2 unknowns, so therefore we can use those coordinates to help us make 2 equations and solve simultaneously. Or, as you'll see in this case, what's going to be easier is to use one of the coordinates and see if we can work out either the p or the b and then substitute that back in. Okay, so we can use the method of substitution with the simultaneous equations. All right, so I'm going to use the point -1 and -3, and I'm going to substitute it into this equation that we've now changed because we know what the value of q is. All right, so I substitute it in. So y is -3, x is -1. So I'm going to get -3 in place of y is equal to b to the power of x, and we know x is -1, plus p -4. All right, guys, hopefully you can all see what I've done there. It's nothing very dramatic. All I've done is I've just substituted the coordinate in to our equation. Okay, and I'm going to try and solve for the value of b. All right, so we take the 4 over to the left-hand side, becomes +4 -3, which is 1, is equal to b to the power of -1 plus p. All right, how do we solve this? All right, and I wish that I actually had someone screaming here, screaming out the answer. Hopefully you're screaming out the answer at Abram. But how do you solve this? You've got b to the power -1 plus p is equal to 1. How do you solve this? All right, the only way to solve this is to use exponential equations. All right, how do we use the exponential equations? Well, we can rewrite 1 as b to the power of 0. Okay, because remember, where you are solving for an exponent, you need to have the same bases. All right, so I can rewrite 1 as b to the power of naught. Now, since the bases are the same, I can equate the powers. So therefore, 0 is equal to minus 1 plus p. Therefore, taking the minus 1 over, I'll get p is equal to positive 1. All right. Okay, so we've got p is equal to positive 1 by substituting the coordinates of minus 1 and minus 3 in place of x and y. So now our equation changes slightly again. It's now going to become y is equal to b is still unknown, to the power x, and p is 1, so it's going to be x plus 1, and then minus q, which was minus 4. Okay, so our equation, as you can see, has evolved. Now we only have one unknown. Okay, you can see that the only unknown is the value of b. How do we find the value of b? You go back to your graph, and you see that they've given you the coordinates of another point on the graph. They've given you the coordinates 2 and 4. So you can use these coordinates and substitute the value for x as 2, the value of y as 4, and then solve for b. So we're going to use 2 and 4, put it into that equation and solve for b. So this is what it's going to look like. We're going to say, okay, y is 4 times is equal to b to the power of x. X is 2 plus 1 minus 4. So we get 4 is equal to b to the power of 3. 2 plus 1, 3 minus 4. Therefore, taking the minus 4 over to the left-hand side, we'll get 4 plus 4, which is 8, is equal to b cubed. All right? To get rid of that power of 3, I can then cube root both sides. The cube root of 8 is 2. So therefore, we get b is equal to 2. Okay, so now we have all our variables. We know that b is 2. We've worked out the value for p. We've got the value of q. So now we can write the defining equation for this exponential graph that they've sketched for us as y is equal to 2 to the power of x. Remember, what was the value of p? It was 1. 2 to the power x plus 1 minus 4. Okay. And that is the equation of this graph. Guys, what you can do, and I always like to do a quick check. Remember, we have the coordinate 2 and 4 on the graph. You can quickly just substitute the x value of 2 and see if you get the y value of 4 to make sure that your equation is right. All right? So if x is 2, I'm going to get 2 to the power of 2 plus 1, which is 3. So it's 2 cubed minus 4. 8 minus 4 is 4. All right, so you can just quickly check one of the coordinates to make sure that you've got the right equation.
Now it's time for a break, so don't go away. We'll be right back. Welcome back from the break. I know you can't wait for the term to end and the July holidays to start. And of course, that means winter school. This year, we will be repeating all the term 2 Learn Extra live shows for you from the 24th till the 28th of June, from 9 a.m. in the morning till 7 p.m. at night. So don't miss out. Go to our website www.mindset.co.za/learn/extra/winter school to get all the details and to download the notes for each lesson. But for now, let's get back to today's revision lesson. Over to you.
So far, we've looked at how the value of p and q affect your exponential graph. We drew an exponential graph, and then we also found the equation of an exponential graph and touched on how you can find equations of parabola and hyperbole depending on what information you're given. So for the last question, we're going to look at graph interpretation. And again, I reiterate, grade 12s, this is so important. Functions are a huge chunk of your marks at the end of the year, and it doesn't have to be a difficult section. All you've got to do is practice, practice, practice. Okay, so this comes from, once again, Keeping Maths Simple, and this is grade 11 learner's book, page 177, exercise 5.21, and we're looking at number 6. Okay. You might see a few blocks here. Just ignore those little blocks. They don't really affect your equations. Our equations on the diagram represents the graph of f of x is equal to minus x minus 2 squared plus 4, and g of x is equal to 2 to the power x plus 1 minus 4. Okay, let's have a look at the graphs. So you can see they've given you the graph of f, which is the parabola, right? So that's our graph f in orange. And then in white, we've got the exponential graph g. Okay, so you can see they're intersecting. We've got a whole lot of coordinates and points on the graph and so on. And the first question says, calculate the following. Okay, and it wants us to find the length of OE. Okay, so that's from there to there. Before we look at that question, remember, let's just analyze what we've been given. You've got the function, the parabola, minus x minus 2 squared plus 4. Hopefully you guys realize, and I mean, it's good to have an understanding of what you're looking at. If we've got a negative graph, a negative a value, we're going to have a sad graph, okay? Important thing about the value of a being negative is that you have a maximum turning point. Okay, remember? Negative because it has maximum problems. Okay, so important point. Then if you look at your exponential graph, what do we notice? The value of a is 1. B is a value that's greater than 1. B is equal to 2. So therefore you have an increasing graph. And it's important to analyze these points because even though, if you look at the questions, we just asked to find length, there could quite easily have been a question here saying, does the parabola have a maximum or minimum turning point? So you would need to be able to understand that without even looking at the graph. You can look at the equation, you can see, okay, a is negative, so therefore I've got a maximum turning point. We could also say, is the exponential graph increasing or decreasing? So it's important concepts that you need to understand before you tackle graph interpretation. Okay, let's get stuck in with the question. The first one is to find the length from O to E. Okay, so if you look at this distance, OE, okay, so we're going from the origin to that point E there. Right, you will notice that E is the x-intercept of the parabola, and O is at the origin, and it also happens to be another x-intercept of the parabola. So if I want the distance OE, what I need to find is the coordinates of E, and then all I need to do, because we've got a horizontal distance on the x-axis, once I've got the x coordinate, all I'm going to do is subtract the two x coordinates to find the distance from O to E. So the x coordinate at point O and then the x coordinate at point E. How do we do it? So this is part A. So we're going to use f of x is equal to negative, let's just get that equation back. It was negative x minus 2 squared plus 4. All right. How do you find x-intercepts? To find x-intercepts, remember, we say let y be equal to 0. Okay, so we're going to get negative x minus 2 squared plus 4 is equal to 0. And remember, we solve for x because we want the x-intercept. So we get negative x minus 2 squared is equal to negative 4. Guys, I'm going to do it. I mean, you can times your brackets out on that. I'm going to do it in a slightly different way. We divide through by the negative 1, so we get x minus 2 squared is equal to positive 4. So at this point, you can times this bracket x minus 2 squared, bring everything to one side, and then factorize a trinomial. But what I'm going to do is because I've got two perfect squares, I'm going to square root both sides. So therefore, I'll get x minus 2 is equal to, remember when you take the square root, plus or minus 2. So therefore, we'll have x minus 2 is equal to positive 2, or x minus 2 is equal to negative 2. All right, so the first one gives me x is equal to 4, and then the second equation gives me x is equal to 0, which makes sense because remember when I showed you the graph, one of the x-intercepts was at the origin, so it was the point 0, 0. Okay, which means that this must be the coordinates of point E, E must be the point 4, 0. So, if you want the distance from O to E, we know that the x value at point E is 4. We know that the x value at point, well, at the origin is 0, 0. So all I'm going to do is subtract. I'm going to say 4 minus 0, and I'm going to get that the distance from O to E is 4 units. All right. So OE is equal to 4 units. Okay, and guys, this is a typical question. You know, if you've got points on the x-axis, we often ask you to find the distance between the 2 points. If you're looking at the x-axis, it means you're looking at your x-intercepts. All right, let's move on to the next one. Here we are asked to find the distance O to D. Okay, so O to D, let's see, is it a point on the parabola or the exponential graph? And you see that D is actually a point on the exponential graph. Specifically, it's the y-intercept. So it's the point where the x value is 0. So if I want the length from O to D, which is that vertical distance, all I need to do is to find the y value at point D, and then I'll get the distance from O to D by saying the y coordinate at point D minus the y value at the origin, which is 0, and we'll get that distance. All right, so here we're looking at the exponential graph. Okay, your equation here, g of x is equal to 2 to the power x plus 1 minus 4. Okay, so g of x is equal to 2 to the power x plus 1 minus 4. We're looking for the y-intercept. So we're looking for when x is equal to 0. We let x equal 0. We get 2 to the power 0 plus 1 minus 4. So that's 2 to the power 1, because 0 plus 1 is just 1. So we get 2 minus 4, which is negative 2. So therefore, the coordinates at point D are 0 and negative 2. So we know that this is the point 0 and negative 2. If I want to find the distance from O to D, I'm going to say the y-coordinate at the origin minus the y-coordinate at point D. So I'm going to say 0 minus 2, and we get minus times a minus is a plus, so we get positive 2. So therefore, the distance from O to D is 2 units. So OD is equal to 2 units. We're on to part C. All right, so let's just get that moving. C, we need to find the length from O to C. Okay, and I'm just going to now erase some of the other things I've done on this graph so we can have a look at OC. All right, and OC is from the origin to a point on the exponential graph. Not just any point, a specific point. This is the x-intercept of the exponential graph. So if I know what the value at point C is, if I know what the coordinates are, I can simply subtract the 2 to find the distance from O to C. All right, so how do we find x-intercepts now? We're looking at the exponential graph. To find your x-intercept, you let y equal to 0. So in the equation 2 to the power x plus 1 minus 4, we let g of x be 0 and solve 4x. Again, we're dealing with exponential equations, which you guys did in the first term. So we'll have 2 to the power x plus 1 is equal to 4. I've just taken the negative 4 to the other side. 4 we can rewrite as 2 squared. Guys, remember, whenever you're solving an exponential equation and your unknown is in the power, then you've got to make your bases the same. So therefore, once the bases are the same, we can equate the powers. So therefore, x plus 1 is equal to 2. So therefore, x would be equal to 2 minus 1, which is just 1. So therefore, the coordinates of C are 1 and 0. So the distance from O to C, remember O was the origin, the distance is simply going to be 1 unit. Okay, so it's going to be the distance from 0, 0 to the point 1, 0, which is just simply 1 unit. Okay, and quickly let's have a look at D, which wants us to find the length BC. Okay, so let's have a look. BC is that point just above the x-intercept of the exponential graph. In fact, it's in the same vertical line. So therefore, the x-coordinate at point C is also the x-coordinate at point B. So if I want to find the vertical distance from B to C, I need the y-coordinates at point B. How do I do it? Well, we know that they're in the same perpendicular distance, so therefore the coordinates at C, which was 1, 0, implies that the x-coordinate at point B is 1, okay, because they're on the same, as you can see, they're on the same vertical. So therefore, the x-coordinate is 1, and I need to find the y value. All right. Remember, whenever you're looking for vertical distances, you're always dealing with y-coordinates. All right. So we know we're using, once again, the parabola f of x is equal to negative, you can never remember this equation, negative x minus 2 squared plus 4. And guys, it looks like we are running out of time, so I'm going to leave part D for you to do by yourself, but I will give you a hint. Okay, remember, we know that the x value at point C is 1, so therefore the x coordinate at point B is also 1, as I showed you. So we substitute 1 in place of x and we solve for y. All right, so we get minus 1 minus 2 is just negative 1 squared is going to be just 1. So I get 4 minus 1, which is 3. So therefore the coordinates at point B is 1 and 3. Okay, so that's the coordinates at point B. And all we're interested in, because remember we're looking at a vertical distance. So all I want to do, if I want the distance from B to C, is I'm going to look at the distance between the y values. So I'm going to subtract the coordinates. 3 minus 0 is going to give me 3 units. So therefore, the distance BC is equal to 3 units. It's just the vertical distance, so it's the difference between the y values on your graph. Okay, so it was just that distance there. And it's only, remember, you don't always do this when you want distances. It's only because these were on the same perpendicular line. All right, quickly, let me give you a hint for part D. Okay, for part E. If you want the distance FG, okay, so look at your graph, and these graphs are up there for you. If you want the distance FG, it's a horizontal distance, guys, but very special. This lies on the line y is equal to negative 4. It lies on the asymptote of the exponential graph. So you know that all along that line, your y value is equal to negative 4. All you've got to do is take that negative 4, substitute it as the y value of your parabola, and then solve for x. And you'll be able to find the distance FG. All right, thank you guys for joining us today. We've covered so much of work, and I hope you've learned a lot.
Okay guys, I hope you're enjoying this revision session. If you are struggling and need help, remember to post on the page or send an email to helpdesk@learnextra.co.za. Now it's time for a break, so don't go away. We'll be right back. here selecting highlights from previous shows, you can still follow me on Twitter @LearnExtra or post or comment on our Facebook page, facebook.com/LearnExtra. Right now, let's do some more revision.
So guys, what I want to do is I just want to remind you quickly of what you did last year. Last year in grade 10, you learned to find the average gradient between 2 points on a curve. So let's do a quick recap because that is important for some of the work you'll do in grade 11 as well. All right, so this comes from the Keeping Maths Simple grade 11 learner's book. This is the example on page 167. Okay, we are told to calculate the average gradient of the graph y is equal to x squared minus 4 between x is equal to 1 and x is equal to 2. So if they say average gradient between 2 points, the way you do it is to find the gradient between those 2 points. So you find the gradient of the straight line between those 2 points, and that gives you the average gradient of the curve. Okay, so guys, I have already got this drawn for you. Okay, and I'm just going to show you what we mean on the graph. Okay, so we've got one point A, which has coordinates 1 and minus 3, and we've got the other point B, which has the coordinates 3 and 5. Okay, and you've got to find the gradient between those 2 points A and B. Okay, and I'm just drawing it in so that it's a little bit clearer for you guys. There we go. So if I draw a straight line from the points A to B, then the gradient of the straight line AB will give me the average gradient of the curve between the points A and B. So all I do to answer the first part of the question, the average gradient between those points, I'm going to say, well, I know I use the formula for gradient, and this is the gradient of AB. We know that's going to be y2 minus y1 all over x2 minus x1. Okay, A, remember, has the coordinates 1 and minus 3, and then B has coordinates 3 and 5. Okay, just while we're at this point, I just want to point something out to you because I've already drawn this and I've got the points on the graph. But guys, remember, if you didn't know what the y values are on this function, they've given you the x values, right? So if you wanted the y values, all you need to do is substitute those x values into your defining equation and then work out the y values. Okay, so you would put 1 in place of x and you'll get minus 3 as the y coordinate, and if you put 3 in, you'll get 5 as the y coordinate at point B. Okay, so you can work that out if they don't give those coordinates to you. All right. So now I'm just going to plug in the values straight from my coordinates. So I'm going to start with this one from B. So I'm going to say 5 minus, use brackets so that you don't get confused with your signs. So it's 5 minus minus 3 all over 3 minus 1. Okay, minus times a minus, you times that in. Minus times a minus is a plus. 5 plus 3 would give me 8, and 3 minus 1 gives you 2, so 8 divided by 2 is 4. All right, so therefore, the average gradient, okay, we're answering the question, the average gradient of the graph between 1 and 3 is 4. Okay, it's what we've worked out there. All right, and remember, that's the gradient of the straight line A and B. Okay. We're going to look at the next part of this, which also a very important concept. It also comes in a lot when you're doing graph interpretation. And the next part says, for which values of x is the graph increasing? And then the second part, where is it decreasing? Now remember, when is a function increasing? We've done this in the previous lessons. Okay, a function is increasing when your x values, as your x values increase, your y values increase at the same time. So if your x values are increasing and your y values are increasing at the same time, then your function is increasing. If, however, as your x values increase, your y values decrease, then you have the opposite thing. You have a decreasing function. So if we look at our graph, let's look at what's happening. If you look at this part, okay, all the way from here up until the turning point, which is on the y-axis at 0 and minus 4, all that way, as your x values are going up, so as they're increasing, as they're getting more positive, look at what's happening to your y values. They're going down, they're decreasing. So what do you have? From there, if we had to find the gradient or the average gradient, it will all be negative. So therefore, in that whole section of the graph, we are dealing with a decreasing function. All right? But how do we write this out? Okay, you can't just say it's a decreasing function. We want to know for what values of x. We see that it happens all the way from all the negative x values all the way up until this point, up until this turning point, so up until that point there. All right? The corresponding x coordinate is 0 at that point. Okay? So therefore, we've got x decreasing all the way up until 0. But then look at what happens. As you go from that point onwards, your graph starts increasing, because as your x values are getting bigger, as they're getting more positive, you can see that your y values are also increasing. Okay, so therefore on this side, we have an increasing function. Okay, so let's write this down as they wanted, which they said is for what values of x is the graph increasing. So increasing, remember that's what I've highlighted in orange. So the graph is increasing for all values where x is greater than 0. Okay, so for all values x greater than 0, your graph is increasing. And then the second part, where is the graph decreasing? It's all values up until that point where x is 0. All right, so it's when x is less than 0. So when x is less than 0, the graph is decreasing. We have a decreasing function. And when x is greater than 0, you have an increasing function.
We've come to the end of today's show. Thanks to Macmillan for making the show possible. And thank you for joining me and for participating in this revision session. Remember to visit our website, learnextra.co.za/live to get the notes and to watch the videos. If you are stuck on any questions, send an email to helpdesk@learnextra.co.za and tell us where you are stuck. All the best for your exams.